welcome guys. So today we are proving these three integration corresponding to cosecant x. So before I prove, please subscribe to my channel, click the like button, and leave the comment below. Okay, so what we need to prove today is these three integration of cosecant. So all we need to know, two things. One is the cotangent derivative is minus cosecant square, and the cosecant derivative is minus cotangent cosecant. Okay, so the first one I already proved in the video, so I will not prove it. And the cosecant square, right? You just move this negative sign to other side, so integration of our cosecant square is the minus cotangent. Okay, so all the non-trivial things is this one, and this one is basically the cosecant cube. So I can write the cosecant cube as a cosecant times cosecant square, and this is the cotangent. Okay, so by integration by part, I can write as this one minus, and there's a minus sign, so become plus cotangent, and the differentiation respect to the cosecant. Okay, so this is negative cotangent cosecant. Okay, so this one is minus cosecant x, cotangent x, minus cosecant x times cotangent square. So cotangent square can be written as cosecant square minus 1. So let me just remind you guys this one. Okay, so you see this term is same as this term. So this is minus cosecant x, cotangent x, minus cosecant square plus cosecant x. Okay, so and this is equals to cosecant cube x dx. So you see these two terms are the same, so you can move it. So it becomes 2, right? So and divided by 2, so we have the first one, and so we have the a half cosecant x, cotangent x, so it's the first one. And this one can be reduced this, right? Just plug a equals to 1. So we get minus 1 divided by 2. So put in here. So we have this plus c. Okay, that's it. So using the first one and second one, we can prove the third one. And next time we will prove the cosecant to the power n, although it's related to the second to the power n. And you can check my other integration videos. Thanks.